We can do even more. Imagine the size of our screen is only this big. But if the content we need to display, such as the height of this text, has already far exceeded the displayable range, then we can actually change the origin of the layer contained in this text view by detecting the movement of the swipe gesture or pen gesture. And then we can just mask out the exceeding parts, and you can achieve the effect of the scroll view. So now we add it to our standard components, and you may have felt it again that views are just a thing that uses both rendering and gestures to achieve different effects. Next, let's take a look at such an interface. It's pretty simple, just a picture with a label and a button below it. I hope you focus on the label or the title in the middle. So how should we calculate the position of this label? Or how should we define it, right? If viewed from the most primitive rendering or from the layer angle, then we need to add the y-coordinate of the image to its height, and then finally add a little spacing to find the specific origin of this label. But there's a problem with this method. If we let developers calculate this way every time, the information they depend on is just way too much. Imagine that it's not just this label. If many other things need the size and position information of this picture to calculate, then when our designers want to, say, delete this picture, we need to make a lot of changes. Another problem is, suppose our picture moves to a new position or say it changes its size, then the developer still needs to update everything again. And we don't even have a way to know at once which things are related to this picture. Because everything only access the position information of the picture once and use it to update its position, and we did not store this relationship. What methods do we have to solve these problems gracefully? Perhaps we can let our developers define a relationship directly and then store this relationship inside a view. Whenever these views change, we automatically update the position and size of all the associated views based on this relationship, and then take these updates from the hand of the developers. And it also enhances the overall readability of the code. In actual applications, these relationships will be called constraints. They can not only define positions, but also define relationships and values for sizes. If you want to know more, you can search for the keyword auto layout online. Now let's take a look at an example in the real world, and this is just a screenshot of Apple Music. Let's focus on the first card. You can pause and think about the different views inside this card. One possibility is that we have a label view for Apple Music at the top, and of course, it could also be an image view. Below is the favorites label using the both fonts, and then below that is the label of the for the mix. And at the bottom, we have the label for the song's author, which has a semi-transparent view behind it as a background. And behind everything, there might be an image view. And if you open the real application, you might find that the background of this card is animated, so it might actually be something more complicated. But let's just treat it as an image view for now. Next, let's try to define their position using our newly created constraint system. At the very top, we have this Apple Music logo. We might say that its top anchor is about 10 pixels away from the top anchor of the image view, and then its leading anchor is also about 10 pixels away from the leading anchor of the image view. Notice that I said leading anchor, not left anchor, because we need to consider that many languages are read from right to left. So we need a dynamic adjustment layout definition method that can be adjusted according to the reading direction of the language. Leading in the context of English means it's on the left. And similarly, the position of the favorite label can also be specified in a similar way. Only this time the top anchor is bounded to the bottom of the logo. auto layer will help us walk through the entire layer tree and try to determine their specific location at that time. And the mix label is pretty much the same. I won't go into the details here. And the author label at the bottom is more interesting. Its size is purely determined by the constraints, or rather, our layout system will get the final size by subtracting the spacing on both sides. And great, we now have a convenient layout system for our developers, and we almost didn't use any new tools outside our toolbox throughout the process. So we return to this example. Remember the problem I just mentioned that if we remove things, we need to update many values, right? We didn't even have a convenient way to find out whose positions and size depend on other views just now. And now it's much more simpler. But in fact, we haven't completely solved the problem. If we need to add, say, a new view, we still need to make a lot of updates. For example, this new category label we just added between the title and the image. If only relying on constraints, but looking in the vertical direction, then we only need to delete the original constraint between the title and the image and then add two new constraints. But for more complex layout, we need to update much more things. So do you still remember how we designed the draw method? We get some information somewhere and then present this information in a structured way. For example, if we have a string, we render the corresponding characters at a certain spacing. So can we treat other views and the spacing between them as kind of information to a special view, to let it use this information to render and arrange these arranged subviews? In this case, whether we're removing or adding a new view, it's actually just changing the information given to this special view. It can just be a simple array storing these views that need to be laid out. Given that all these subviews are lined up linearly, let's just call this a stack view. The problem is solved like this. We no longer need to specify the relationship one by one. All we need to do now is just add these new views to the stack. And the stack can be responsible for changing our specific layer trees and the layout. And even more wonderfully, this stack itself is also a view. We can allow our developers to put it into other stacks or even horizontally. What we just created is a tool that allows developers to create complex interface in the simplest way. And in our next workshop, you will see how this idea is further developed by SwiftUI, a more modern UI framework.